Hi everyone, this is lesson 4.7 for Algebra 2, and what we're looking at now is scale changes of our trigonometric functions. So in the last lesson, we learned what the trigonometric functions look like originally. Those would be like the parent functions. In this lesson and really the next couple of lessons, we're going to start doing transformations on these things, which is going to take us way back to chapter 3. Back in chapter 3, we learned about doing, translations, so slides, left, right, up, down. We talked about scale changes, so vertical stretch, vertical shrink, that kind of thing. That's all coming back in this lesson. Okay, so you're going to have to really kind of dust things off for yourself. You'll have to remember all of that stuff. So there's two aspects of the graph that we're going to be concerned about today, the amplitude and the period. And you are more than welcome to pause the video right now if you need to get those definitions written down. But I'm going to talk about the original parent function in terms of these terms. And then as we go through the examples today, we're going to start messing with these values a little bit. We're going to start changing them up. So we talked about the period yesterday. Period is the horizontal distance, okay, that it takes to complete one full cycle. So this is the sine function that I'm looking at here. And if I measure like from this point to, and then this is where the graph would kind of start over and it would head back up again, my horizontal distance is from 0 to 2 pi, okay? So my original parent function has a period of 2 pi. And I should make a note here that this is the parent function because, like I said, once we start doing transformations, that's not always going to be the case, okay? If you're having a hard time figuring out, where does this cycle start repeating, start picking a couple points that are a little more obvious. And you may have to be good at fractions for this, but like, for example, I could go from the bottom of this bump to the bottom of this bump. I know those two things correspond with one another. So if this is at negative pi over 2 or negative 1/2 pi, and this is at 3 over 2, the distance between those two things is still 2 pi. So you can pick any 2 points on the graph that correspond and measure the horizontal distance between them, and that'll give you your period, okay? Now, the amplitude is a vertical measurement, and I don't think that I use that word here, so you may want to make a note here that amplitude has to do with the vertical size of the graph, and really what it's measuring is like the height of these bumps, the height of your maximum or the depth of your minimum, okay? Either way, this is your amplitude, and this one would have an amplitude of 1, right? We talked about how the maximum and the minimum are 1 and -1, so we would say that the amplitude of the original parent function is just 1. Okay. So now what we're going to do is we're going to transform one of these functions. And I think this first one is actually looking at the cosine function instead of the sine function. You know what I think I want to do? Because the next example talks about the sine or the cosine function. Let's change this one. Let's make this a sine function. So we're going to look at 5 times the sine of x over 2. And we're going to compare it to this original parent function. Okay. Really, being a sine function or a cosine function isn't going to change much for us, but I just wanted to differentiate it from the next example a little bit. So to graph this thing, I'm going to use Desmos, and you may want to use Desmos for these as well. I'm sorry, I have it in here as a cosine, but we'll change that. Let me just talk about a couple of things with Desmos. Desmos is nice for these trig graphs because you can really see, you can change how your x-axis is numbered and you can really see what's going on, I think. To make those changes so that it's numbering correctly, you're going to go over here to the settings, the graph settings. And let's see, I've changed mine up a little bit, so I'm going to delete these and we'll start from scratch here. If I want this to number like a normal trig graph, I'm going to go from maybe, I don't know, -3 pi up to +3 pi. So I'm typing in -3, and then when I want to type pi, I know you can't see what I'm typing, but I'm just typing the word pi, P-I, and it'll automatically show up there. And then I'm going to make it go up to +3 pi. You'll see that now my x-axis is numbered that way. And then in the step position, that's what do you want it to count by? I have it set to count by pi over 2. And on your y-axis, this can kind of change, and of course you can adjust this if you need to, but I'll go from maybe -7 to +7 because I just want to be able to see above and below the graph as well, okay? And of course you can set it to be in radians or degrees. Typically with these we're going to be using radians, so I would just get used to that. so now let me type my actual function in. The function was y equals 5 times the sine of x divided by 2. Okay, now I'm going to close this part so we can see what's happening here. Okay, and just for comparison, I'll go ahead and put in just the regular sine function, y equals sine of x, so we can see the difference between the two. So first of all, you'll notice that the amplitude is much higher, right? The red graph goes up much higher than the blue graph. The blue graph has that amplitude of 1 that we were talking about. This on the y-axis is a 1. Notice the red graph goes all the way up to 5. It now has a maximum at 5 and a minimum at -5. So, and I'm going to show you what I'm writing down in just a minute, but under example 1 for amplitude, I'm writing that my amplitude is now 5 instead of 1. And then I want you to look at the periods. So my original sine function, the blue graph, it took a distance of 2 pi to complete one full cycle. Now when I'm looking at the red graph, in that same distance, I'm only completing half of the cycle, right? I have to kind of stretch this out to be able to see one entire cycle of the sine function. It now takes me from 0 to 4 pi. So my new period is 4 pi as opposed to 2 pi. Okay, it stretched things out for me. But notice that that y-intercept stayed in the same place. Okay, I didn't move from that 0, 0 y-intercept, so my y-intercept is still at 0. Okay, so now let's look back at our notes here. Those are the things I wrote down based on our discussion just a minute ago. Amplitude is now 5. Excuse me. Period is 4 pi. Y-intercept is still at 0. So I want us to think back to chapter 3 when we were writing our rules for these things, writing our rules for scale changes. Remember, rules look something like this. And then I say, what happened to x, what happened to y? So the rule is always backwards from the equation. And I should really say that the other way around. It's the equation that's backwards. The rule is telling you what's actually happening to stuff. The equation has to put everything in as backwards to compensate. So remember when we wrote our rules and we said x plus 4 in the equation, you would really put an x minus 4. That's the same kind of thing that's happening here. So when I see that x is being divided by 2, in my rule, I'm going to write it as being multiplied by 2. And that'll make sense to you in a minute when we talk about these things up here. Okay. Now for my y value, that 5 is what belongs to the y, right? Because we talked about how anything that belongs to the x will be in parentheses with the x, so anything that's out here must belong to the y. But that means that if I put it back over with the y, where it would have originally been, it would have been a divided by 5. And then my rule does the opposite of that. So my rule would be 5y. Okay. Okay. So in this rule, the 2x is affecting this graph horizontally. If I was to ask you back in chapter 3, if I was to give you this rule and say, hey, what does this thing do to my graph? You would have told me this was a horizontal stretch and a vertical stretch. Okay. A horizontal stretch is going to affect the period because the period measures a horizontal distance. Okay. So this is telling you what is happening to the period. And I guess I should not just say that. I should say the effect on the period. And this is telling you the effect on the amplitude. Okay. So think about our nice parent function that we started with. Our original parent function has an amplitude of 1. And then we applied this to it so that amplitude of 1 got multiplied by 5. And that's where we got an amplitude of 5 from. That one seems pretty self-explanatory, right? Basically for this, whatever is happening to the y, that's going to become your new amplitude because you're applying it to a 1. The period one can be a little bit trickier because the original period was 2 pi and our rule says we're doubling that. Right? So we're going to take 2 pi and double it, and now our new period is 4 pi. Okay? Technically, our y-intercept would get multiplied by these things as well. It would get multiplied by these things as well. However, because it's a 0, it's not going to change anything, right? So I would not worry so much about the y-intercept, but these two things you should understand. So in general, and that's what this little space down here is for, and really we're just going to write down kind of the same thing we wrote here. is if I give you a size change rule, like this, where something is happening to X and something is happening to Y, your new period will be this A value times what the original period would have been, which is 2 pi. And your new amplitude will be this B value times the original amplitude of 1. And again, this one is really easy because anything times 1 is just itself. So I can just look at this and say, okay, that thing right there is my amplitude. But the period, you have to think about applying that to a 2 pi to give the new period value. So just as an example, because I know the next one is going to be really similar to this one we just did. If I gave you a size change rule, and you guys can choose to write this down if you want to, but if I gave you this, oh, and that shouldn't be SX. What am I doing? It should be SXY. If I give you this, 3x and then 1/5 y. And I said, okay, if I apply this to a function, what is my period and what is my amplitude? For the period, you would say, I'm going to take my original amplitude of 2 pi and multiply it by 3. So you would tell me my amplitude is 6 pi. I'm sorry, my period is 6 pi. So sorry, guys, it's late. I'm saying things wrong. You would tell me my new period is 6 pi. That where it used to only take me a distance of 2 pi to complete a full cycle, now it takes a distance of 6 pi. My amplitude would be this number really times 1, which is still just 1/5. So now my graph, instead of going all the way up to 1 and down to -1, it would only go as high as positive 1/5 and down as low as -1/5. So that's how you can use these rules to come up with your new period and amplitude. Okay, let's try one of these. I'm going to come back to the frequency definition here. We'll talk about frequency in just a minute. Okay, let's just take a look at this graph here. So what I've given you here, and I apologize if I was projecting this in class, you'd be able to see this in color. But this smaller graph here is the original cosine function. And I know I'm looking at cosine because of the location of the y-intercept. So that's my cosine function. And then this one here is a transformed cosine function. So I've done something to it. Okay. So what I want to know first is just what's the period and what's the amplitude of this new cosine function. And then we're going to use those two things to write a rule. And then once we have a rule, we can write our equation. Okay, so, and I made this point a lot back in chapter 3, that you always need a rule. That's kind of your first focus is what's my rule? And then you can do all the other things. Okay, so looking at this transformed function, looking at this bigger function here, if I want to know what the period is, maybe this would be a good way to test yourself. I would pause the video right now and see if you can find the period and amplitude of that transformed function. I'm going to look at this from the top of this bump to the top of this bump. That's one full cycle, and that is a horizontal distance from 0 to 4 pi. So based on that, I'm going to say that the period is 4 pi. I could also go from like the bottom of this bump to the bottom of this bump, and that would be -2 to 2, which is still a distance of 4 pi. Okay, so the period of my graph is 4 pi. My amplitude is the height of these bumps, so how high off the x-axis is this? And this looks like it has a height of 4, so I would say that my amplitude is 4. So now I want to take these things and come up with a rule, right? My rule has to look something like this. And then I'm going to have like something x, comma, something y. To figure out what these values are, I have to ask myself what happened to the period and what happened to the amplitude. So for this one, I'm asking myself, if my original period was 2 pi, what did I have to multiply by to get a 4 pi? Well, I would have to multiply by 2, right? That's my A value. That's the number that's going right here. This one's easier, Okay, I'm still going to write it out just so you can get the idea, but my original amplitude was 1, and I want to know what did I have to multiply it by to get it to turn into a 4? Well, that would just be a 4, and that's giving you your b value. So my rule would be 2x, comma, 4y. I did a horizontal stretch, which made my period get larger, and I did a vertical stretch, which made my amplitude get larger. So now let's write the equation for the image. Let me start with my parent function. Y equals cosine x. Well, I should have spread that out a little more. That's okay. Remember, when I go to put my rule into my equation, everything goes in reverse. So really this would go in and become an x divided by 2 here. And this would become a y divided by 4. With these functions, we always get the y back by itself. So I'm not going to leave this as y divided by 4. I'm going to multiply by 4 and put it over here on the other side. So my final equation will look like this. Y equals 4 cosine of x over 2. Okay, let's talk frequency really quick. So frequency is probably a term that you've heard in the context of one of these graphs. It's the number of cycles completed within 1 unit of the independent variable. That is a confusing way for us to think about frequency, but it's really saying, you know, if I go from 0 to 1, or however this is numbered, 0 to pi over 2, how much of a cycle have I completed? What fraction of a cycle have I completed? I think the easier way to think about frequency is to know that it is always, always, always just the reciprocal of the period. Okay, it's the period flipped upside down. So for this question, if I'm asked about the frequency, it is as easy as taking this thing and flipping it over. So my frequency would be 1 divided by 4 pi. Now, if my period was a fraction already, I wouldn't mess around with the 1. I would just flip my fraction as is. But we're just going to leave it like that. That is hard for me to show to you visually on the graph what that means. So if you can just remember that it's the reciprocal of the period, you'll be okay. We're not going to talk about this all that often to where you'll have to be able to like show me on the graph what that means or anything like that. As long as you can tell me that it's the reciprocal of the period, you'll be okay. Okay, so now let's look at example 3 here. Example 3 wants us to sketch this function as compared to the original sine function, and that's what I've given you here is the original sine function. I know that because it's centered at 0, 0, okay? And it has an amplitude of 1. If you notice how this is numbered, if this is 2, this has a height of 1. So this shouldn't shock you. The first thing I'm going to think about is a rule. I'm going to ask myself, what is happening here to x? What is happening here to y? Remember that your rule is going to be reversed from how your equation is written. So where I see a 2 times x in my equation, I'm going to put an x divided by 2 in my rule. That means my period is going to be cut in half. My 2 pi is going to be divided by 2. And if we think of it in terms of what we learned in chapter 3, that's going to be a horizontal shrink. That's going to take this thing and push it inward. It's going to make this thing cycle faster. For my amplitude, or for my vertical change here, this is being multiplied by 0.5. So remember, if I moved it back to the y, I'd be dividing by 0.5, but then of course I do the opposite here. So this is really going to be like a 0.5 y. As a quick rule of thumb, whenever the number is from the y is moved over here to the right, your rule is just going to reflect that exact same thing because it's like it's already been flipped. It's already been, the opposite piece has already been taken care of. Okay. 0.5y would be the same as y divided by 2 as well. That's the same thing. Okay, so now let's think about what effect this is going to have on the period and the amplitude of my function. Okay. My original parent function period was 2 pi. If I look at this graph that's drawn here, my period is 2 pi. This is what's happening to it. So I'm taking 2 pi and dividing by 2, and now I'm going to have a function that completes a full cycle between 0 and pi. Just so we know visually, this is 0, this is pi. So our original function does like half a cycle between 0 and pi. Our new function is going to do its entire cycle between 0 and pi. I didn't mean to actually write there, sorry. Okay, so we're going to fit in one complete cycle between here and here. Okay, we also have to think about what's going to happen to the amplitude. My original amplitude was 1, and this is telling me that my amplitude is going to get multiplied by 0.5, which means my new amplitude is just 0.5. So now, instead of going all the way up to 1, the height of my graph is just going to be right here at 0.5. Okay, and the lowest point of my graph is going to be at negative 0.5. So I am shrinking this thing vertically. I am also shrinking it horizontally. Okay, if I'm going to complete one full cycle between here and here, that means kind of the midway point of my cycle needs to be here. So I'm going to come up and land back down at the x-axis here, and then I'm going to dip down and come right back up to the x-axis here. There's one complete cycle between 0 and pi. And then I would just keep repeating. I'm going to go up, back to the x-axis, down and back to the x-axis. So in the space of 2 pi, I've completed 2 full cycles. Okay, and I could keep going as long as you really sketch one full cycle. Whoops, I kind of squeezed that one in there. So go up, down. Ugh. Sorry, I'm not nearly as good when I don't draw my marks in here. So I have to complete one full cycle between here and here. That means I want to be back at the x-axis here. So up and down, down and up. Okay. We're going to get into this a lot more technically eventually, where we actually take points from the original graph and translate them. For right now, I just want you to have kind of a visual idea of what's happening. Okay. We can also think about it as, every one of our x-intercepts is getting cut in half. It's getting shrunk. So this point gets moved to here. And so that's how I know to be landed back at the x-axis by that point. And I could continue that pattern here to the left as well. But I would say for your purposes, knowing this piece of information is more important to me than your artistic skills. Okay. However, you should understand what this is going to do to the graph visually. Okay, and you do have Desmos to help you out too. So we could take this thing and type it into Desmos, and you would have an idea of what's happening here with this orange graph. Okay, that should be enough to get you going on lesson 4.7. Hopefully you found that helpful. And when we get to lesson 4.8, we'll start talking about translations instead of scale changes. So you have that to look forward to. All right, have a great night.